For those of you that have been following my channel, this is a follow-up to my last video, part 6 of vehicle integration. And the way I left it was I still had one, what I would call minor issue, that the battery saver enable system was activated after 20 minutes of driving because the engine was not running. I really wanted to find a solution to eliminate all error messages that I would get on the DIC. This video shows how I solved that problem. And for those that have not been following, I would recommend going back and looking at my last video prior to this, and that'll give you some additional background. So I addressed this battery saver active issue through the CAN bus. And I did this with the following methodology. First, I created a CAN sniffer uh, setup with the Arduino and an add-on called MCP 2515. This allows me to monitor all the activity on the CAN bus and record it if I need to. And I connected this circuit to the OBD2 port on the Corvette. There's a program that's available on the internet that is called CAN Hacker. And this is one method. There's other methods, but this is a methodology to basically you load up the Arduino with an IDE for CAN Hacker. Then you shut that down and open up CAN Hacker, and then you begin to read all the data flow through the CAN bus. And I had that set up, and then what I did was created another Arduino circuit and connected that by the engine computer, and that circuit simulated the engine crankshaft sensor input into the engine computer. And I did that by creating an IDE for the Arduino that represented a 58 plus 2 crankshaft signal. Now, when I do that, and I mentioned this in my part 6 video, I get a myriad of other error messages because now the body computer and the engine computer, of course, realize the engine is running now and some other things are not working like they should because I don't have them hooked up. So I was looking for another solution to avoid that problem. And but by toggling the 58 plus 2 crankshaft signal on and off, I could see which data bytes changed, telling the body computer that indeed the engine is running or not running. And of course, if the engine is running, then the body computer will no longer generate the error message about battery saver mode being active. So that was my objective. This is a chart of the output from the CAN Hacker under the two scenarios of without the crankshaft sensor operating and with the crankshaft sensor operating. And as you can see highlighted in blue, the two data bytes, big data bytes 1 and 2 of the IDE 110 is what changes when the engine computer is sensing the crankshaft sensor operating. So pretty straightforward. My next step was then to test this, and I used the CAN Hacker software, and you can actually interject into the CAN bus a signal to represent an input into the CAN bus. So I did this, and sure enough, by interjecting the two new bytes of data for ID 110, I was able to eliminate that error message after 20 minutes and not impact anything else. So mission accomplished. So my next step was to just create a permanent circuit to input that signal on a regular basis as I'm using the car. So these next few images just show how I made a permanent circuit and mounted it next to the engine computer in the right front quarter of the Corvette. So this circuit is just so you can see inside what I did with the Arduino and the MCP 2515, and then closing up the box. So there's 4 wires coming out. 2 wires will be the twisted pair that connect to the CAN bus at the engine computer, and the other 2 are the power and ground. And this just shows a picture of me um, testing it first with alligator clips, inserting the signal uh, at the engine computer, and the last video, just for perspective, for those people not familiar with the car, this is where the engine computer is located. There's 2 large terminal connectors, and this is in the right front fender well. So with my newfound knowledge of how to crack the CAN bus, my next project, and I pretty much have done with it, I just haven't fully wired it up yet, is cruise control for the electric Corvette. The controller that I use, and you've seen earlier videos on the controller, has 2 inputs. One is to turn cruise on, and the other is to turn it off. And right now I just have a toggle switch activated for that on the side of my console for testing. But I want to use the existing Corvette cruise control controls on the left stalk, which you see on a lot of products in the vintage of this Corvette. And I've done all my testing. I can tell which data ID and bytes change as a result of the different cruise settings. So I can use the existing cruise switch to control cruise. And that'll be a future video uh, for my uh, for my YouTube channel.